Good evening, everyone. We're going to start in about 5 minutes. We're waiting for Deputy Minister Jan Dusick, who says he's just 5 minutes away, so we'll wait for him to begin. Thank you. Thank you, everyone. We're going to go ahead and get started right now, and we appreciate you giving up a portion of your precious Saturday evening after a very long and trying week at this COP. This side event is on slow onset, irreversible impacts beyond adaptation. We're looking at features such as the global stocktake implementation, and in particular, the degree to which we are meeting the 1.5 degree ambition. This is a joint event between 6 organizations, actually: Climate Analytics, Climate Central, the International Cryosphere Climate Initiative, the Scientific Committee on Antarctic Research, the Karuna Foundation, which works in Bhutan, and Climate Policy Center. So without any further delay, I would like to introduce our opening speaker, Deputy Minister of the Czech Republic for Environment, Jan Dušek, who has a long history of activism both in the civil society world as well as the UNEP Arctic ambassador, as well as an advisor to WWF Arctic, as well as the Czech Minister of Environment at COP15 in Copenhagen. So there are very few people, I think, that we'd rather welcome more to open this event. So please, Honorable Deputy Minister, go ahead.
Well, thank you very much, Pam. And first of all, apologies for the delay. I was told that Memphis is in a completely opposite part of the compound. So thank you for spending an extra few minutes, and thank you for inviting me. Thank you for your very kind words, which I don't think I deserve, but I'm very happy that I can be here with you and plant another part of the discussion about the importance of what the melting of cryosphere means in our current discussions here at COP27. And indeed, the Czech Republic has the European Union presidency at the moment. This week has been very busy also in Brussels. We are discussing the internal EU legislation to implement the Paris Agreement and to do our share of the 1.5 degree Celsius. And I'm very happy to report that we have now approved 3 pieces of new legislation in the European Union that deal with first, emissions from cars, bringing only CO-neutral cars by 2035. Second is the effort sharing regulation, how we bring ourselves on the commitments outside of the emission trading scheme. And the latest one is the land use change and forestry. So these 3 pieces of European Union legislation are now agreed, and we are moving on with the remaining pieces, and all that puzzle should bring us to European Union at least 55% reduction by 2030. And why I wanted to mention it, that obviously when we talk about the melting of the ice and sea level rise, we are in a decisive decade, and we of course we are also committed to getting to net zero as quickly as we can, but we are also committed to reducing the emissions as quickly as possible in this decade. And I'm very happy that we can, as the European Union, bring these pieces of news to COP27 and invite others to make corresponding commitments. We know that the current NDCs are not compatible with Paris pathway. We have a long way to get to the 1.5 degree, and everyone needs to step up. We are stepping up as well, and paradoxically, maybe because of what's happening with geopolitics and energy in Europe, it actually speeds up our dedication to decarbonize and to get rid of the dependence on the fossil fuels. So this has helped, and maybe we will be able to do even more than we originally thought of the 55%. So that's the European Union message, that we are coming here. And then obviously, having been part of discussions and policy making in the Arctic in particular, it's a bit strange to see ourselves discussing polar issues in the middle of the desert in Egypt, but I think that it is very important to connect the dots and to show the significance of what's happening with the ice and where we stand and what this meeting should deliver. That the ambition needs to be scaled up, that the time is running out, and the effects that we are seeing and that we will be seeing not by 2030, not by 2050, but by the end of this century and onwards are very significant. And we need to listen to the science. We need to interpret that science and turn it into policy action. One event of our Czech EU presidency was that we've hosted a meeting in Prague to discuss exactly that, and we were happy to welcome some of the negotiators, some of the scientists, and we are very happy that also at this COP there will be a launch of a coalition to support the cryosphere topic to become more mainstream, because it's important for the whole world. So thank you for inviting me, and I'm looking forward to the event.
We'll now have 3 scientific presentations. The first is from Florence Coglione, who is with the Scientific Committee on Antarctic Research. So Flo, please.
So many thanks. Actually, we were speaking about desert. Polar areas are other desert kind of areas. So I think there are some matches somehow. So tonight I wanted to focus especially on Antarctica, not only because I'm a SCAR representative here, but also because most of the uncertainty that we have on sea level projections owe to Antarctica and what we don't know about Antarctica. So just to summarize a bit what we know about the sea level projections. So by the end of the 21st century, okay, the low emission scenarios and the high-end scenarios both shows that we are committed to almost half meter or above almost 1 meter of sea level rise, global mean sea level rise, with a contribution of Antarctica that is rather small, because you know that to sea level there are other contributors like ocean expansions, Greenland, mountain glaciers, etc. So why do we focus on Antarctica if the contribution of Antarctica appears to be so small? So most of the impact of Antarctica is to be expected on the long term, and this is because most of the ice sheets absorb the heat on a very long time scale. As such, they melt on a very long time scale. It takes a few centuries for them to really release the heat that they have been accumulated for centuries to millennia. So if we look at the projections that IPCC showed recently in the last report by 2300s, we can see that we are committed to at least 1.5 meters of global mean sea level rise, with almost 1 meter due to Antarctica. And if we look at the high-end scenarios, okay, we are committed to almost 6 meters, with half of it owed to Antarctic contributions directly. Why is it? Antarctica has a very particular feature. So it's an ice sheet that is grounded mostly above sea level. So what you see on the right-hand side, the map is showing what is below the ice, actually. So everything that is brownish, okay, is the subglacial topography that is above sea level. But everything that is light blue is the topography, the bathymetry that is below sea level. And on most of those light blue areas, the ice sheet is grounded, okay, it's not floating. That makes the difference, because it means that it is highly vulnerable to the oceanic warming that is occurring around the margin. So basically Antarctica, it's not only like Greenland. Nowadays we know that it's not melting from the surface, but mainly from below. So when the glaciers in Antarctica flow from inland to the ocean, they start floating because the ice density is lower than the water density, and they form floating platform, floating termination of the glaciers that we call ice shelf. And those ice shelves are very sensitive to all the oceanic warmth that is brought from below. In the next future, when temperature will be higher enough to trigger melting at the Antarctic surface, we will also have melting at the surface, as we can observe now in Greenland. But those marine parts of Antarctic ice sheets, they are very subject to instabilities, and this is the part that is responsible for the uncertainties that we have on sea level projections. So what's happening? From a dynamical point of view, those ice shelf, those floating part, okay, thins when the ocean is warming because they are melting from below. When they got too thin, actually, the flow from inland is not enough to sustain the existence of this floating platform. So what happens is that they disintegrate, and then there is a very fast retreat of the glaciers that translate into a fast discharge and a very fast sea level rise. So this is what we call the marine ice sheet instability. There is another kind of instability that can even foster this marine ice sheet instability that is due to atmospheric warming, as I said, in a very distant future when there will be some melting at the surface. The meltwater will infiltrate the crevasse, and during the winter time it will froze again and will create hydrofracturing that will help further to disintegrate those floating parts. And this will trigger an even larger discharge and larger sea level rise. So both instabilities actually are very difficult to observe because it takes as fast as 2 centuries to occur. Okay, so we have some suspect that in some areas now in Antarctica it's occurring, both in the west and in the east. But the trigger is fast, we know that from the past, so it can be a tipping point in oceanic temperature, it can be a tipping point in atmospheric temperature, but then it has a very long-term consequences with multi-meter sea level rise, larger than 4 meters. And this is an example that shows you the projection to 2300 in one of the most sensitive sectors of West Antarctica right now. This is Pan Island Glacier and Thwaites Glacier area. So you can see that in 2 centuries, most of the area is disintegrated. Do we have evidence of such instabilities because we are not able to observe them right now? So the answer is yes. By looking in the past, we are able to evidence that those instability happen, those fast retreat of the glacier happen because they leave some traces on the bathymetry, and we are able to date back all the steps of the retreats, and we know that such instability occurs within 6 centuries, broadly. We have evidence from West Antarctica, from the Ross Sea, but also now from East Antarctica. So those are ground evidence. We cannot deny that this happened, and this happened in different periods in the past. So what happened to our sea level projection then? With those instabilities, they rise up a lot. So in the low emission scenario, we reach 2 meters, with most of it due to Antarctica marine ice instabilities. And in the case of the high-end scenarios, we are up to 15 meters of sea level rise just because of disintegration of those sectors. So this brought us to sea level commitment, which means that the amount of sea level we commit to depends on how much and how fast we mitigate our carbon emission. And I say that because past data show definitely that it's no science fiction. If we look at a very past one period where temperature was 5 degrees warmer than today, so we know that sea level was higher by 20 to 30 meters. Then to the mid-Pliocene, which is a period where it was 2 degrees warmer than today, with a CO2 a bit above 400 ppm, so a bit, close future, we are around 20 meters of sea level rise. And then closer interglacial periods with even less warming, so 0.5 to 1.5 degree warming, so the target we are trying to reach. We are around anyway 20 meters. Or 5 to 10 meters in some case, but we were still talking about multi-meter sea level rise. So now if I put our projection in this perspective, you can see that it's completely in the range of what the paleo data say to us. So to conclude this talk, I would say sea level rise anyway is unavoidable because of the thermal inertia of the ice sheets. Even if we stop warming today, we are committed to at least 2 or 3 meters of sea level rise. So this implies that we will have multi-generational adaptation that is needed, but only if it will reach limits of adaptation with continued emissions. That's why we need to continue to mitigate and reach this target of 1.5 degrees. Thank you.
Thank you very much. I'm going to give a very brief overview then of mountain glaciers moving from the polar regions. The one thing I will say that Jan Dusek said at the beginning is that, you know, here we are in Egypt talking about polar regions, but the amount of sea level rise that Flo showed that we could have in as little as 200 years, perhaps less, would inundate much of the Nile Delta region, about half of it, which of course is the breadbasket of Egypt. You can see this outlined in the State of the Cryosphere report, but this is going to be looking at, you know, upstream and downstream issues related to mountain glaciers and what we can expect. Land and mountain glaciers, the biggest ones, if you're looking at sea level rise, are in the high latitude and high altitude regions, especially high latitude. But the ones that I'm going to be mostly focusing on are ones that are a little bit closer to home. Mountain glaciers and snow are a reliable seasonal water resource for drinking, for power generation. There are many regions of the world that are reliant on these resources for seasonal water. Switzerland, for example, right now it provides water for agriculture in August, but we would see shifts that water would mostly be coming down in June when it's not needed and would not be available in August. These are the kinds of shifts that will occur with higher levels of emissions. And our emissions today do make a difference tomorrow. This is a paper that was published just a few weeks ago. It shows the Great Aletsch Glacier in Switzerland. Here it is in 2017 on the left. With high emissions, the glacier is essentially gone already by 2100. With low emissions, it preserves about half of it. So what we're doing today really does make a difference. But what I really want to emphasize here is you can look at the ice sheets and glaciers. The ice sheets are smaller versions of the ice sheets. And we are now in a very, very steep period of loss of glaciers because of warming that is already in the atmosphere that the glaciers have already absorbed. And if you look here at tropical glaciers, including those here in Africa, there's very little difference in many ways between high, low, and medium emissions. They are almost all of them destined to disappear even with low emissions because of the heat already built into the system. For mid-latitude glaciers, we have a little bit more hope. And here you can see a real divergence between high emissions especially and low emissions, which are in the blue. Particularly in the Alps of Central Europe, we even might be able to see a little bit of regrowth. But again, going back to the ice sheet comparison, as you can see, through about the middle of this century, almost all the way to 2100, these lines don't diverge. Again, that is because there's already heat in the system. So think about an ice sheet. If we continue emitting, even to 1.5, we're going to commit ourselves to that kind of rapid loss that will continue not for decades, as you see here with many of these smaller glaciers in the mid-latitudes, but with an entire ice sheet, and then it goes on for centuries. And that loss is committed even if we start taking temperatures down again. And as you can see here again, in a couple of these regions, and again, particularly the Alps, very slow regrowth, but it's only, as you can see, a few percent a year. And so this is really an irreversible impact, a few percent per decade. So it takes a very small amount of time with the kind of warming we've put into the system from carbon emissions to make glaciers begin to or entirely disappear, but it will take centuries to millennia to grow them back again. And finally, the water towers in particular of the Himalayas, there is a fair amount of difference, especially between low and high emissions, where we can prevent the loss of these glaciers if we manage to follow a low emissions pathway. That would mean a peak of about 1.8 degrees. So well below 2 degrees, and of course much better at 1.6 degrees, which is very low emissions. Finally, I want to put in a bit of a plug for snow. Snow is actually more important in many ways for drinking water and water resources. It's been arriving later, it melts earlier, it covers less ground, you lose some albedo, and again is very important, probably more important than glaciers for the ecosystem services that glaciers and snow provide. And we need to preserve this as much as possible. It is less irreversible, it will come back faster if we're able to hold temperatures down, and that is a bit of a good news story. So more detail is available in the State of the Cryosphere report. We have a few copies with us here, but you can find it online or come to the Cryosphere Pavilion to speak to some of the scientists that you'll actually be meeting a bit later. So thank you very much. Our next speaker is Andrew Pershing, who's going to tell us what this looks like in reality, in future, depending on which emissions pathway we follow. He is with the senior scientist at, or director of climate research, actually, at Climate Central.
Thank you. Okay, thank you very much for giving me a chance to talk to you, and I really appreciate the introduction to the science by the two previous speakers. What I'm going to do is really talk about the stakes of what we face when we're making these choices between the 1.5 degree target and our current trajectory. So this is Alexandria here in Egypt. It's of course an ancient city, amazingly culturally and historically important. This is what Alexandria looks like through the lens of some of Climate Central's mapping tools approximately around 2030, so not very far away. So you see just a little bit, some red dots on some of those spits of land. That indicates that those places will experience some flooding due to sea level rise over the course of the year. So if we flip forward to, if we flip forward to 2050, right, you can see a large red area that appears on the south side of the city. This is an area that will experience flooding at least once per year. And I'm going to zoom out so that you can see where that's coming from. It's really coming from, as I believe Pam mentioned, coming from the inundation of the Nile Delta, which Alexandria is a coastal port for. So you see that flooding coming in from the landward side. Okay, now zooming in back into Alexandria, we can also start to think about, so this is the fast response. This is the response that we are experiencing right now. But we have this longer term, slower response where the timescales are much more uncertain, but where the magnitude is actually reasonably well constrained. And so what we're going to do is now look at those long-term consequences of sea level rise, building on those on the 1.5 degree targets. So the color shifted. So now the light blue area is actually the area that would be underwater under 1.5 degrees. Note how it was very similar to what we were looking at under 2050 or 2070, those earlier maps. So it really looks a lot like the city that we essentially are committed to already. And it gets to the point that Florence made about adaptation being an intergenerational challenge. The red pixels are what we lose if we go past 1.5 degrees and on to 3 degrees. It may take several centuries to get to that point, but that will be several centuries where this city of Alexandria will be extremely challenged. And of course, this is happening all over the world. In order to visualize some of these stakes, one of the things that the team at Climate Central did was to go into Google Maps and get some of the three-dimensional renderings of some of these buildings, and then put together visualizations of what the expected sea level will look like. So here is the Abdul al-Abbas al-Marsi Mosque in Alexandria, under 1.5 degrees of warming. You notice there's no water around. But under 3 degrees, that plaza in front of the mosque is flooded, right? And so think about the loss of that cultural resource. Think about the loss of the access to this important part of the city. So here it is in 1.5 degrees. And so now what I'm going to do is really go through a few other quick areas here in Africa and focus on starting with 3 degrees and then what happens if we implement the ideas that are being discussed behind us and maintain that 1.5 degree target. So today in Tunisia, you'll notice not a lot of water. With 3 degrees, much of the city gets flooded. But if we hold emissions in check and limit warming to 1.5 degrees, then the city, we keep a lot more of the city, and the changes happen more gradually, and so adaptation is easier to contemplate. Here's another city in Tunisia. We lose 1.5 degrees, the water goes away. Moving into South Africa, we also have here at 3 degrees in Durban, South Africa, large plazas, right? Major parts of the center part of the city are flooded, and at 1.5 degrees, that flooding goes away. So I've been showing you some of the resources that Climate Central has. We have maps and visualizations from many places all over the world. I was just highlighting Africa. So picturing our future is the tool that allows you to look at 1.5 versus 3 degrees. And you can actually play with different targets. You can look at 2 degrees and the impact of 1.5 versus 2 if you'd like. And then our Coastal Risk Finder is our main resource that allows you to produce maps of various kinds looking at particular times or particular flood levels. Both for adaptation planning like we've been talking about here, but also for potential emergency response. So, thank you very much.
We're now going to move to talking about what this means in terms of where we are right now in the commitments from governments, or perhaps where we are not. I don't know if the two of you wish to share a presentation, or Bill, if you're going to speak first. Yeah, okay. This is Bill Hare, of course, who needs no introduction, but he is the founder, I believe, and director of Climate Analytics.
Yeah. Thanks, Pam, and thanks to the earlier presenters. I'm just going to go through the other side of the picture, which is where we stand now on emissions, and also maybe look at a bit of optimism towards the end. And in between, Uta is going to present some work on the cryosphere and climate change. It's very relevant to this discussion. Now, where we stand now, I guess everyone's aware of the Climate Action Tracker, but every year we do an update of where we stand in terms of what the global temperature outlook is. And this year we did it again here in Egypt, and the bottom line is the world is heading towards 2.7 degrees of warming under current policies. The needle didn't shift since we calculated this in Glasgow last year, unfortunately. It's been a terrible year, one way or the other, for people in the Ukraine and for energy and climate policy. And we've basically seen very little progress in improving it. The targets on the table, as we calculated them here in Egypt, would, if fully implemented, limit warming to 2.4 degrees. The very optimistic outlook that we have says, well, if you look at all of the net zero policies on the table, even though they aren't matched by 2030 targets and actually did it, then you'll get down to 1.8 degrees. But that's a very, very optimistic and unrealistic interpretation of where we stand. So the bottom line is that we're a long way from where we need to be. Now, we have begun to narrow the 2030 emissions gap over the years. There's been some narrowing going on, the gap between where emissions are headed under policies and actions or NDCs, pledges and targets, and where they need to be for the 1.5 degree pathway has indeed narrowed a bit, but it remains very large. And we know from IPCC assessments that we need to be getting down into that green zone in order to have a decent crack at limiting warming to 1.5 degrees mid-century. Now, we know also that, and I wanted to emphasize this, that 1.5 degrees is still within reach. For those of you living in the Twitter world, you will see that there's a massive amount of questioning of this going on in the community at large, and I think everyone knows and feels that we're under an enormous amount of pressure and basically policy is not really working. But the IPCC's found that it's still possible to get there if we can take fast enough action. We can close the 2030 emissions gap, we can do it. The emphasis needs to be on getting out of fossil fuels quickly and accelerating the uptake of renewables. I think we all know that, and removing fossil fuel subsidies. We know that the role of the finance sector is critical. We know that not enough resources is going into renewables now, and that we desperately need to have those financial flows, both public sector and private, aligned with the objectives of the Paris Agreement. We know that the window is closing rapidly on 1.5 degrees, but from the physics end of things, we know that if we can get that pathway, 50% reductions, net zero CO2 by mid-century, then we have a decent crack at limiting warming to 1.5 degrees. And there's a lot of stuff happening out there in the world now. 10 years ago, you would have been hard-pressed to find a big event that you could link to climate change, but science has moved on and the climate system has warmed, and we're seeing more and more extreme events, whether they're hydrological or heat, that we can link quite strongly with attribution statements to climate change, human-induced climate change. The Pakistan floods, tens of millions of people displaced, has a very strong human-induced component to it. The Horn of Africa drought probably has a climate change link. We're not as certain as about the Pakistan floods, but the point here is that we're just seeing systematic changes in all of the basic Earth system parameters, whether it's ocean acidification, temperature, extremes, the melting and loss of glaciers, as well as the emergence of really strong extreme events linked to climate change. Now, we know that essentially only halving emissions by 2030 is going to provide that capability of protecting the cryosphere. And now, Uta, if you'd like to come up and run through the results of your work, that would be great, and I will return to finish off with maybe a bit more optimism on how we can actually switch things faster.
Yes, thank you, Bill. And yeah, as Bill said, I will now talk a bit about emissions and the cryosphere and how only halving emissions by 2030 can minimize risks of crossing irreversible cryosphere thresholds. A bit closer, thank you. Okay. Yes, so to set the scene, emissions pathways as assessed by the IPCC Working Group 3 have a range of possible temperature responses. And this substantially increases the risk of crossing thresholds in the cryosphere, even under low emissions pathways, due to the risk of potentially high warming outcomes. And so, yeah, these temperature ranges need to be explicitly considered when assessing the risks of crossing thresholds. And this is all from a comment that we currently have under review, so please don't take any photos. But yeah, we hope to have it published soon. So this figure is from our comment in review, as I said. And on the left-hand side are different cryosphere elements. And on the x-axis are increasing levels of global warming. And yeah, the figure shows that for different cryosphere elements, threshold risks increase with every bit of warming. We've heard this before also from our previous speakers. And many thresholds are already at 1.5 degrees of sustained warming. And yeah, as we've also heard before, some losses are irreversible on centennial or even millennial timescales. And so, yeah, this figure then shows ranges of possible temperature responses to different emissions pathways. And it reflects uncertainties in how exactly the climate system will respond to emissions. And so there's a large range of possible temperature outcomes, even in Paris Agreement compatible pathways, which is in the top row. And so this also shows that NDCs, which is in the bottom row, even if they are strengthened in the middle row, could reach warming levels under which crossing thresholds is not just a risk, but the most probable outcome. And yeah, just to summarize, so the thresholds in the cryosphere in the top panel overlap with ranges of possible temperature responses to emissions pathways. And this makes a strong case for stringent mitigation, which is why we're all here, in line with the Paris Agreement's 1.5 limit. And yeah, only such pathways provide still a chance of avoiding critical cryosphere thresholds. And now I hand over to Bill. Thanks.
So I was just going to finish up here a bit. Thanks, Uta, for that, with what's needed to get to 1.5 degrees, and show you some of the results if I can make this thing work. I'm having a struggle with the computer here. We better? Okay. So, a bit of a glitch. I think that everyone's aware from what we just talked about, looking at the macro emissions level, that things are not going well. But if you unpack that into a whole bunch of different indicators on decarbonisation, which has been done by the System Change Lab and published in the State of Climate Action 2022 report recently, then you'll find that many of our critical systems are not on track. Didn't find any really off track, 6 indicators, well off track, 21, some are going in the wrong direction. So that is not a very optimistic picture, and you can tell that by the temperature projections that we've actually got out there for you, putting that all together, looking into the future. Now, on the other hand, there are some promising signs. We see a very rapid growth in solar and wind electricity generation. We see this is happening quite quickly. We can see the beginning of what might look like a heavily exponential curve, right? So it's not as though we're looking at a flat curve. The curve is inflecting upwards, which means that we're starting to see more rapid penetration of these clean technologies into the power system. Now, looking at it from another perspective, from the classical S-curve of technology development, where you start off slow, you go in the middle through very rapid deployment and flatten off towards the end. And looking at the previous figure, zero carbon power from solar and wind, you see at the bottom of this curve, we're very much at the point where we should and could see a very rapid inflection upwards towards 75% plus renewables by 2030 globally. Now, what we diagnose here is that this rate of penetration of renewables that we've seen in the last decade needs to be increased by factor 6 or so in order to get to where we need to be. It's not unimaginable, and we see already promising signs in individual countries where that's happening. We know that if we can swing climate finance, private sector into this, that it's achievable. Looking at the other side of the equation, coal, the phase-out's going 6 times too slow. It needs to be accelerated by a factor 6 in order to get to where we need to be out of coal by 2030 in the OECD, 2040 globally. We know that fossil gas is not a bridging fuel. We've done work, others have done work, which shows that despite the fact fossil gas power is increasing globally, it actually needs to be phased out quite quickly. It's not often understood in the community at large, but the phase out in the power generation sector is only 5 to 10 years slower than in coal. So the International Energy Agency's net zero update released a week or two ago shows that essentially total gas use globally needs to be 30% down by 2030, 60% down by 2030. That tells you gas is not a bridging fuel. Now, we know also on the optimistic side that technologies have shown that systems can flip rapidly. So we know that the cost of utility scale solar power generation has dropped by 88% over the last decade. We know the cost of onshore wind is falling quickly. And we know these system transitions are happening in individual countries. The issue is scale and rapidity of rollout. But that's optimistic to know that this could happen. The IPCC has shown that this 2030 emission gap, which looks enormous, can actually be closed. It's actually possible to do it. We have a variety of different tools to look at this, whether they're top-down integrated assessment models, and you can question what's in those, or bottom-up sectoral mitigation studies, which take very much a granular approach. Put it all together, the IPCC shows that this can be done. So it's not a matter of a lack of technology or know-how. We know that clean energy investment basically is not going fast enough. This is a great figure, didn't actually find its way into the summary for policymakers of Working Group 3, but the State of Climate Action report has resurrected it in a nice way, and it shows the gap between the average flows of investments in different regions compared to the average mitigation investment needed to get onto a 1.5-degree pathway. And you can see the very big gap there. But what is really critical is that there is sufficient global liquidity out there. there's sufficient cash, in other words, to close the gap. And that needs to be one of the big focuses of policy. We know fossil fuel subsidies are too high. I said earlier that getting rid of fossil fuel subsidies was a critical part of policy. Well, look at what's happened in the last couple of years. They've actually gone up. So that's a big challenge. Now, just to return to the cryosphere issue, and Florence, I really like your presentation, but I just wanted to recall, what you're basically showing there is an oncoming disaster, multi-metre sea level rise commitments. Now, just over 44 years ago, John Mercer, a geologist and geographer, published in the journal Nature in 1978 a paper with a rather prophetic, if not shocking, title. The title is West Antarctic Ice Sheet and CO2 Greenhouse Effect, the Threat of Disaster. A well-known paper from a very eccentric scientist who was well ahead of his time, but that's the situation we find ourselves in. The prophecies of the scientific community 40 years ago are now in much greater detail, much better knowledge, but the disaster is still oncoming, and we simply don't have CO2 emissions going down, they're going up.
Thank you very much. And I think what we're going to do now is, in a sense, in recognition of those 40 years that we sort of ignored, we're very privileged at the Cryosphere Pavilion to have groups of early career scientists who volunteer there. And I've asked 3 from this past week and 1 who has actually just arrived to come up and give their reflections quickly on what they've just heard. Then we'll see if there are any questions, but otherwise we will move back towards the food that we have, which is, as we said in the flyer, locally sourced. This is from Egypt that we have brought in with us, and I guarantee that it's good. So if you could all please come up. And our first speaker will be, I would say, since she's first, come on, everyone up at once so we can save a bit of time. Arthi Ramachandran, who is from Canada. So if you want to go first and just give maybe a minute or so of reflection on what you've heard here tonight.
Yeah, thank you, Pam, and also thank you for the opportunity to come to COP. I think it's been a very eye-opening experience for sure. I think all of these presentations really highlighted the need that we needed to, change yesterday, and now we're a little too late, but it's still not too late to at least save some areas and to save some people. I think a lot of the cryosphere, there are some irreversible effects that we have created, but that doesn't mean that all hope is lost. And I think that if we can, come together, all these countries, especially, the ones that are emitting a lot, and commit to actually lowering our CO2 emissions, we can see maybe a hopeful, brighter future for the next generation, for my son, for everyone's children's everywhere. So I think there's still a bit of hope left, so let's keep pushing. Thank you.
Thank you, Arthi. And I neglected to say her research has to do with microbes in the Arctic Ocean under Arctic sea ice. Next is James Kirkham of the British Antarctic Survey, research on ice sheets.
Thank you, Pam, and thank you for the opportunity to speak today and to be here this week under quite a historic summit. I'm generally quite a deep thinker, and I think the sights, the lessons, and the thoughts that I've experienced this week will stay with me for a long time, and I think I'll be chewing over the things I've seen for several weeks to come right now. At times I've been pretty despondent about the state that humanity is in, and seeing these graphs, these figures, these facts on the screen here really underlines that. I've met people who have been impacted by climate change already, have lost their homes, people who live within a few kilometers of the sea in the Nile Delta, and have asked me, what shall I do? Where will I go? Where will I move my home to in the future? But I've also met a number of extraordinary passionate and brilliant people, many of whom are in the audience today, and you give me hope. I think what I do wouldn't be possible if I didn't believe, even in some aspect, there was still a small sliver of hope left. And that's really motivating, and I think we should all hold on to that. The fact that people are here today, they're so passionate, driven to making this change happen, means that we can actually utilize and achieve and recognize the small possibility of making this change happen, permanent, and really establishing a world that we all want to live in the future. Thank you.
Thank you, James. Next is Bimo Narula, who is of Nepal, but is working on Arctic sea ice at AVI in Germany. Please.
Yes, thank you, Pam, and thank you to ICCI, Amy, and Emma for all the work you've done. And like James said, and like Arti said, I'm also very happy to have been here, to have experienced what it is to be in COP, and to have been able to talk to everybody that was here. And it was a really great experience to talk to all of you and to talk to everybody that was here, and to be able to communicate with people who have had these experiences of facing climate change in their day-to-day life. And all I can say is that a lot of the people feel this sense of urgency, how serious the situation is. And I hope that the people in the meeting rooms also feel how bad the situation is right now. I'm also happy that this is the graph behind us right now, because I also do agree that fossil fuel subsidies are too high. Thank you so much.
And finally, having only arrived in the last 24 hours, but nevertheless being willing to speak, Chen Zhao of China, who is at the University of Tasmania, Bill, and also working on Arctic sea ice and sea level rise. Please, your reflections.
Thank you, Pam. It's pretty the first day of me here at COP, and I'm very excited about everything happening here, and also a little bit overwhelmed. And from today's talk, I think the key message is very simple. We know what is happening, and we know what we are facing, and we know what we can do to get this done. We know our target had to be 1.5 degrees. I just want to add one more comment beyond today's talk. We know everything is going on Antarctica, but we don't know that something is already beyond its tipping point. Something happened like the West Antarctica is already beyond its tipping point. And for the whole Antarctic, what's the future behind the whole ice sheet, the sea level projections, I think we need to make it very clear that we have to make it at below 1.5 degrees. That's a very clear message I think everyone wants to deliver and bring it to the world. Thank you.
Okay, thank you very much. There are times for questions, either of our early career researchers. Okay, we'll run down a microphone so that people can be heard. Arthi volunteered to be a runner, which is what she has been doing much of the week.
Thank you very much. Diana Urge-Forsatz from the IPCC Working Group 3. I'm vice chair there, but I'm not speaking in wearing my IPCC hat, but rather my professor hat and researcher hat. And thank you all for the amazing presentations and the great connections. It was also very nice to hear the reflections of the young researchers. And I'm sorry, Bill, but my concern is to you, because I know you, and I'm so surprised that your report and even your presentation said nothing on efficiency. And it's so frustrating in this whole COP that we know that the whole solution would be completely different if we also emphasized efficiency. Your rate of 6 times increase would not be needed to be 6 times if we had cared a bit more about efficiency. Just let's think about where we are right now. Yes, we can increase clean electricity production enormously to fuel this, but does it make sense that I'm here freezing in my pullover and I have to put on the scarf and everything, and for the whole 2 weeks or whole week we could not persuade them to not over air condition when outside it's really pleasant, and there is absolutely doesn't make sense. And this is just one example of how much we could do, and we would easily could reach all our targets with half as much needing to upscale if we had put more emphasis on efficiency. And it's very disappointing that there is nothing on this at the COP, or we from the IPCC and the Japanese events, but concretely 3 people, although here also there wasn't a lot of audience. But it's very disappointing that when there is a green hydrogen or whatever event behind which there is a lot of industry, but when the real solutions come, which is close to the people, there is very little audience. Anyway, that's one worry why I don't understand why you don't emphasize efficiency much more and demand. But the other in your report, but the other which is a question, and I've been always wondering, and I'm very glad that I can ask this in person, that there is so much uncertainty about these figures, and I'm so surprised that we are throwing about tenth of a degree digits with so much more uncertainty, and we'll draw these very concrete lines. But we know that meeting even the 1.5 degree with certain emissions, it depends on whether you look at it a 50% chance or 66% chance. So there's all these uncertainty assumptions behind,
you said you had a question?
Yeah, that's my question. How come you're not taking account these risks or not displaying more the uncertainties behind these numbers? That there is a risk even with that to go higher. Thank you.
Good to see you, and great points. I guess we just didn't have time to get into the efficiency thing. You're absolutely correct that if we don't do efficiency at scale and quickly, then renewable energy penetration I showed you would need to be probably 12 times actually, and it's critical. And I'm sure that the next version of the System Change Lab, actually a number of the indicators already do deal with efficiency, but certainly take on board the fact that we need to increase that. I think if you look at the European Union, one of the best ways out of Russian gas, as you well know, is basically heat pumps at scale everywhere and all that other stuff on efficiency that would clean it up. Look, on the scientific uncertainties, yes, I mean, I've worked in this area for years. We do the probability numbers, and it is a pretty close call, the 1.5 degrees limit. The IPCC 1.5 degree pathways is 50% chance of 1.5 degrees at the median. It means it could be higher or lower. And we know that that's the situation we're in now because of the failure to reduce emissions in recent decades. If we get onto the 1.5 degree pathways, net zero emissions by greenhouse gas emissions by 2070s, then there's a very good chance that temperatures will actually be going down by 2100, median estimates 1.2, very likely below 1.5, so it can be done, but you're absolutely right. The probabilities could work out exactly the wrong way for us. And if you look at the Climate Action Tracker, we emphasize the median numbers, but we have the range there, and it's big and it's worrying, and I know my colleague here showed that range in her graph. You can see it, so it's something more for a technical audience, but we're all scared about the problem and aware that when we show medians, it isn't the full story.
And I'll simply say that as someone who communicates with policymakers on a regular basis, uncertainty is language of science. Policymakers, it makes it much more difficult to get across the message that you're trying to say. And so that I think is part of the reason that we communicate in the way that we do, because too often uncertainty means we don't know, we don't need to act, we can wait until you're a little bit more certain, which is not usually the message that scientists are trying to get across. Are there any other questions? Yeah, please, Robbie.
So younger generations are often just much more progressive and ambitious than older generations. So do you think when our generation is 50 years old, we'll be just as ambitious and progressive, or will we fade into small c conservatism?
Any takers on that?
I'll take an answer from any of the panelists.
Yeah, I don't know. Oh, yeah, the mic's working. I want to say it's cumulative because we've really gotten aware of how bad things are. I don't think you're as old as I am, so I wouldn't point this at you, but I don't think the older generation were as aware of how bad things are when they were younger.
Hello?
Well, if you
yeah.
get to be as old as me, you'll be panicking. As climate scientists are now, I think there's more radicalism now in climate scientists of any age now than I've ever seen in my career. I don't know what you think, Diana, but I think people are just basically panicking.
Yeah, no, I agree. And I also think that we're in a time where, you know, we can see what's happening everywhere around the world. We can see the disasters. We can see the effects. And I think that has a lot of power to actually see what's happening to people through social media and and live their experiences.
The only thing I'd say is if climate scientists are panicking and alarmed, you should see cryosphere scientists.
I have a kind of trivial question. Well, maybe not for, Climate Central. There he is, sorry, apologies. Your visual images are so powerful, and the way that they were developed, they're intended, I presume, to be a resource, a communication resource for people like me. I'm an advocate in my country, in Ireland. And when your images came through for how climate change or the sea level rise would affect Dublin, this was an incredible thing, because we could say these international experts could look what's going to happen to your city. No effect. I don't understand why it doesn't get the reaction that it should. Or maybe 10% of the audience are reacting and getting it. Maybe it's just part of a patchwork of things that people need to see and hear. But I'm just wondering what your experience is of how the tool impacts on public awareness.
Thank you. I appreciate I appreciate that you liked them and you found them effective. I think it's a fair point. You know, we are talking about this sort of fuzzy future time period, and I think people have a hard time with that length of time. But I think the other thing that we're interested in is whether there are processes where these sorts of tools can become more effective. So just kind of putting them out there in the media without like an action that can be taken, I think can have a barrier where if you come in when a community is making a decision about a resource, I'm really interested in whether these tools actually help people, you know, get over the hump and take the action that they need. So thank you.
Hi, Larry Moffat with the Press Club Brussels Europe. I met Pam by chance at lunch a few days ago. We see more and more countries, cities, industry sectors, individual companies setting reduction targets and net zero targets by certain dates. But aren't those dates meaningless if they don't specify the pathway? Or another way to look at it, I guess, would be the carbon budget. And would it be helpful to set intermediate targets? I know, for example, I think the European Commission is looking at setting a 2040 target in addition to 2030 and 2050 as a way to sort of force a pathway that would minimize the temperature rise and tipping points and so forth.
Well, yes, indeed. I mentioned in my remarks that we are very concerned about what happens by 2030, and of course it's good to have the net zero pledges by 50, 60, 70. But if we don't know the pathway to it, it's less meaningful, and less we will know also how we are progressing if we don't have intermediate targets. For the time being, for the European Union, we have 2030 as the legislation, and definitely we will be looking what happens between 2030 and 2050. But what I want to say also, Pam mentioned that I was a minister at COP15 in Copenhagen, and then I'm coming again in the EU presidency to a COP 12 years ago, and I can see 12 years later, and I can see how much development of technology and deployment of technology there has been that we could not foresee at the time in 2009, 2010. So I think that it makes all the sense to review what's the potential to go faster, to go into more efficiency, definitely, and we cannot afford to just wait and see if everyone arrives to net zero by 30, 40 years from now.
Thanks for the presentation, guys. I don't know if this is going to be a question that people on the panel can answer, considering it's about the Himalayas, but I worked in the Himalayas for about 5 years documenting glacier retreat there in the capacity of a journalist, and I'm just wondering if soot was taken into a factor in those projections that you made, or was it just carbon dioxide?
I actually can sort of answer that, and the answer is no. This is based on, in 2012, it was based on the models at the time. Those have actually been redone, so the graphs would look only slightly different, though, with Glacier MIP 6. But it's climate models that take into account, everything. But in terms of deposition of soot, I would guess not, if I had to answer. Yeah, that's by Ben Marzion. You can probably reach out to him directly on that.
Yeah, that's a good question. I think in terms of understanding certain black carbon and the effect that has on glaciers, that's definitely a field which is beginning to open up now as a kind of urgent priority. And the numbers are still not probably that precise. It's definitely a massive problem. I remember also having worked on a glacier and sitting there one morning and seeing this enormous cloud coming up through the valley and basically blanketing this glacier with dust. And we were digging through the snow, finding black carbon, and then how that helps to darken the glacier, increase melt, that then runs out through the watercourse, and then obviously the effect on that on human health eventually is still pretty poorly quantified. So yeah, definitely a big area of concern and one to really pick up on in future work.
Thank you. In addition to working on Antarctica, James has worked in the Himalayas.
I just wanted to add that, so in the global climate models, they're not included yet, but in the regional models, they are included, and in the next generations, I think they will be included. So there's some progress going on.
Jan?
Not on Himalayas, but to complete the circle on the Arctic, that black carbon is a very important issue in the Arctic, especially in relation to the maritime transport and how to approach first cleaner fuels alongside, of course, decarbonization of shipping, which needs to happen at the global level. And this is what we are addressing here at the COP. We are also addressing it in the European legislation, that this is the big sector which needs to decarbonize. But even before that bracket, we need to see how we can reduce the emissions of black carbon, because they are hugely important in the Arctic in terms of advancing climate change, but also in terms of the population living there.
Just to add on that, I mean, the best way to reduce black soot is to reduce fossil fuel use, right? That's not the only source of it, but most of the reductions you see in the models that are being shown here come from fossil fuel combustion, and that decline leads to substantial reductions. There are also additional mitigation options for black soot, but the main driver is just getting fossil fuels out of the system.
One more question, please.
Hello, yeah, thank you for a great session. I'm Marisa Gould, and I work for the Royal Society in the UK. And I've recently been looking at how the IPCC is discussing in its sixth assessment report irreversibilities and tipping points. And I found a very detailed section, I think, in the main report and the technical summary, but virtually no mention, very little mention in the summary for policymakers of irreversibilities and tipping points. So those of you involved, perhaps, in the negotiations over the summary for policymakers, do you have any reflections on why that might be? Are policymakers reluctant to acknowledge and discuss these tipping points and irreversibilities?
I don't think we have any IPCC authors on this, for AR6 in this particular panel, unless maybe it's Bill, but that would be working group.
Yeah, I guess from my experience in the AR4 and other assessments, pretty much that to get to the SPM level, summary for policymakers level, you need a certain degree of certainty, and it's hard to get, very important things that may not have much evidence or have assessed low probability into an SPM. And I think the situation has improved. I think that if you look at the Working Group 1 SPM last year, there's a lot more there than you would find for a very long time about irreversibilities, major system changes like the AMOC, Atlantic Meridional Circulation, and so on and so forth. So that is changing, and it reflects a couple of different dynamics. The scientific knowledge is changing. I guess the scientific community is feeling more comfortable with talking about low probability, high impact events in an IPCC assessment context. And I think governments are less watchful than they used to be. I think there's some loosening up there as well, but that's just I don't know whether there's anyone else from the IPCC process here to comment or change and contradict what I just said, but that's my overall impression. I mean, one thing to just reflect on is I raised the West Antarctic ice sheet risk, right? This has been a really tough issue for the IPCC from the very first assessment report back in 1990, and the glaciological community was very divided about this. There were those, particularly observational glaciologists, that were literally panicking about this 40 years ago, and the modelers were saying, "Oh, just calm down, it's all going to be okay." And in the intervening period, there's been an absolute revolution in our understanding of the ice sheets. We now know that there are fast ice streams in Antarctica. We didn't know that 20 years ago. We know all these things now that we didn't know, and that's changing the risk assessment and bringing the scientific community together. I mean, I had the task in the AR4 in the census report context of trying to bring together these two different communities, the observational glaciologists, and I won't name them, and the modelers, and you go back to that assessment, you will not find a mention of West Antarctic ice sheet because there was not agreement. And you look now, and it's very solidly there, so the times are changing.
And I will say also, going back to Flo's presentation, not bringing together not only observations and modelers, but also paleo data. And that gives us a lot more certainty. And when you bring those three things together, that's when you get if you look in the SPM of Working Group 1, there is a dotted line, and there was a very long presentation on that actually at the SB meetings. And it's called low probability, high impact. However, the low probability isn't that it is low probability in the policymaker sense. It's only based on a couple of studies actually, and yet the IPCC decided that those studies were so important and well done that they wanted to include that dotted line, and that dotted line is pretty much what someone like Flo, who works on Earth's path, would say to you is actually what we know about how the Earth system responds. So it may indeed be high probability if we continue with our current emissions. I think, unless there's a burning question, I really appreciate those who have stayed for this long on the last day of week 1. As I mentioned, we do have some wonderful sandwiches that you can stand around, talk, ask questions. We will certainly remain, but feel free also to just take them with you and get out of here if that's what you're really desperate to do. Are there any final comments from our panelists? Or Jan, would you like to say a word or two? It says how unusual you are as a deputy minister that you've stuck around. So thank you.
Well, first of all, I was very happy to listen for once and not be talking or negotiating. So I'll have enough of that in the coming days. But it has been inspiring to be part of this discussion, including with the young scientists and seeing whether their generation will be more revolutionary than ours. But definitely, these are important questions that hopefully will land in our thoughts as we approach the Ministerial week and not just the maze of the decisions, but also the vision where the process should be going for the next years in the COP. So thank you for the invitation and for very thoughtful remarks.
Thank you, everyone. Have a good evening, have a good day off, and see many of you back here on Monday.